Hey folks, welcome back to another video. So we were doing top interview 150 questions from Leetcode. We were practicing graphs. In the last video we did clone graph. Now we have one more questions, evaluate division. So let's see. You are given an array of variable pairs equation and an array of real numbers value where equation I is ai bi and value I represent the equation a by b equals to value I. Alright. Each ai bi is a string that represents a single variable. Okay. We are also given some queries where qj equals to cj dj. Okay. Represent a z query where we must find the answer from cj by dj. Okay. Return the answer to all queries. If a single answer cannot be determined, return -1. If input is always note the input is always valid. You may assume that evaluating the queries will not result in division by 0 and that there is no contradiction. Alright. The variables that do not occur in the list of equations are undefined, so the answer cannot be determined for them. Okay. So for the answers that cannot be determined, we have to return -1. So let's open Xcali-Draw. Okay. So what it says that first we will have the equations of a, b and values. So that means a by b equals to 2. So that means okay, let's zoom in. That means a by b equals to 2 and b by c equals to 3 and b by c equals to 3. Now from here we have to find a by c, b by a by e and many others. Okay, so let's take nodes. Okay, let's take the a node, then b, a, b, c. Now what we can do is we can take weighted graphs. Okay, now since a by b equals to 2, so that means from a to b the weight is 2 and from b to a the weight is reverse, that is 1 by 2. From b to c the weight is 3. From c to b the weight is 1 by 3. Now let's take some query a by c. Now what we have to find is that we have to find the route. We have to find the route, and during the route we have to multiply the weightage. So from a to b the weight is 2. From b to c the weight is 3. So therefore the answer is 6. Let's take another one. From b to a it is simple. From b to a it is 1 by 2. That means 0.5. Okay. From a to e, now we don't have a a, so that means we can't find a route. So that means if the route doesn't exist, that means it is -1. From a to a, if it is the same node, then return 1. X, since x is not present, so therefore we have to return -1. This is kind of the Dijkstra algorithm. So let's implement it. We will take help of AI if we don't know, but yeah, let's try to implement it first. We have to create a class of pair to store the weight, similar to Dijkstra algorithm. Int value and double wait public pair devel double wait this dot val equals to val this dot wait equals to wait. Cool. Now for this first we have to create a map. Alright, so for map we have to initialize a hash map. Let's take it. For it will have the node that is the integer and a list of pair. Alright, map hash map. Cool. We have given equation, values and queries. Okay, first we have to what do what is the length of equation length will be always 1, so that means first we can take that we can iterate through the equation for list of string current string of equations. So the first will be string, right? So that means list of string. Okay, we have to take the first one, character, right? No, string a equals to equation current string dot get 0 and string b equals to current string dot get 1. Okay, since it is given that string equation of I will be the length of equation I will be 2. Okay, so we have to put it in the map. So let's take it map dot put if absent. We have to put it like that, since A and B, so we have to put is that for to go from A to B we have to take the values, that means the weight we have to take. It is not, it will be string, okay, A, and it will be a, if we will get a lambda function new array list, okay, then dot add new pair, value will be B and weight will be values of okay, so we have to keep an index also. So what we can do is, let's not do the let's use the classic this one, equations dot since the list, equation dot size I plus plus, so that means it will become equations dot get I dot get 0. operations dot get I dot get 1 pair, and it will be values of I, and from B to A, map dot put if absent B new array list dot add in pair A, it will be reciprocal of this one, values I. Cool. So we have created the graph, sorry, we have created the map. So we have the map. Okay, now what we can do is we can iterate through the queries. Yeah, for we have to do a BFS run similar to Dystra. So let's take it string. We can use this for loop now because we don't need the index right now. We will see what will happen. If we need it, then we can obviously convert it. Queries string A equals to str dot get 0, string B equals to str dot get 1, queries dot like will be 1. Okay, now we have to check. All right, if map dot contains key A, if doesn't contains, or map dot contains key B, if none of these node contains, because as you can see x doesn't contain in the map, so therefore we can directly return -1. Okay, so I think we have to maintain an index because we have to return a double array, right? Yes, so let's keep it answer doubles. The length will be map dot key set, or we can do that values also. No, not values, queries. Yeah, queries dot size. Okay, then we have to also keep the track of this, and I equals to 0, I less than answer dot length I plus plus. Then again we have to do now queries dot get I dot get 0, then queries dot get I get 1. Okay, then it will be answer of I will be -1. Cool. Now we have to do a DFS, right? DFS, how we can do is or we can check this inside the DFS, right? Let's say if map dot contains key A contains key B, then what we can do is return BFS A, B and graph. Okay. Graph means map. Okay. Okay. Let's check it. I have used something like this. Yeah. Let's see. We are getting the graph values, values I, 1 by value, cool result, double creator size, cool start 10, result of I is, yeah, we don't have to contact. Actually, we have to check that in the BFS. Yeah, exactly. Okay. It will be that answer of I will be BFS of AB and map. Correct? Yes. And from here we have to obviously return answer. Now let's get the function of BFS. Public. What it will return double BFS. It will take string of A, string of B and map. Okay. Now the edge cases. If map dot contains key A doesn't contains key, or map dot contains key contains B, then return -1. Okay. We have to create a queue of pair set is a class. We have to define it exactly similar to this one, just because it will help in maintaining the current state, like which one we have added. New linked list, and also we have to initialize a set to maintain which one we have visited new asset. Okay, now first we have to add the node of it's a string, man, it's not this one. Okay, string string. Okay, new pair set. First one will be start and value will be little bit of weight. Okay, start. Yeah, we haven't written the condition if start is same. Yes, if start and end is same, if a equals to b, right? Okay, since it's a graph, it's a string, so therefore we have to see if a dot equals b, and obviously return 1.0. Do we have to return minus 1.0? Yeah, minus 1.0. Cool. That means we have to initialize it with 1.0 because it is start and end. ChatGPT has given a good name, start and end. We can do the same, but yeah, let's keep it like this. Now, while q dot size is greater than 0, we will pull it. Pair set, not set, it should be state. State yeah, current equals to q dot pull we pull it from the queue. We also have to mark it visited, right? Yes, we have to mark it visited dot add. We have to add what? Pair. We have to add state add start. Okay, we have to only the string. Cool. Add a. Now we pull it from the queue. We compare it if current dot val dot equals to b, then return current dot weight. Okay, but we have to do a traversal for pair set neighbor I think this will be pair, right? Yeah. From map dot get current dot val. First we have to check if it is visited or not. If visited dot contains visitor contains, yep, contains neighbor dot val, doesn't contain, yes, doesn't contain, then do the following, then do it as what you have to do, you have to add it, yeah, q dot offer pair state of neighbor dot val, and it will the multiplication of this current dot weight into neighbor dot weight. Got it? And we have to mark it as visited dot add neighbor dot val. Am I doing right? Visited dot add over new neighbor. Yes. Cool. If okay, now off for one. We have done queue, we have added, visited, added, pair. Then now if there is no actually the use case is over, we just have to return something because it's a we have to return a double, and if nothing is happening we will do -1. Okay, I guess that's it. Let's check. Okay, something is wrong. List is not a functional interface. What? Put it absent. Array list. Some syntax error is there. Put absent a list of pair list. What's wrong? Sorry, it should be compute it if absent. Sorry, I've used the wrong method. Okay, again something is there in pair Java new doubles. It's not doubles, it is double. Again pair set, it's not pair set, it is pair state. Again a. What's wrong? String cannot be converted to pair. Visited. Oh, it should not be pair, it should be string. Okay, it ran. Let's submit it. Okay, it got submitted. So let's do a dry run. What's happening? Okay. We were given node A, B, C. These are weighted. Alright. Do we have any other example? Let's take A to B, B to C, BC and CD. That means BC by CD. Okay, it's a string, right? Let's take this A to B, B to C, BC and CD. So something we also have BC and CD. Okay, the weight from A to B is 1.5. So we will have this one. Okay, this is 1.5. It is 1 by 1.5. Okay, now from B to C it is 2.5. 2.5, it is 1 by 2.5. Now from BC to CD it is 5. From BC to CD it is 5, so it will be 1 by 5. So what we did is, to store the pair, we created a pair class. This is the pair class. We first added the graph. We first created the graph. The graph like A is storing B with hand weight of 1.5. B is storing A with 1 by 1.5 and C with 2.5, right? B is storing C with 2.5, right? Then we are traversing to the query BFS start end and the map. So first we have A and C. So first we have to go from A to C. Okay, can we change the color? Yeah. So we have to go from A to C. There's a pointer. Okay, we have to go from A to C. To C. From A to C we will do BFS. Now we also created a pair state so that we can store the current value whenever we are traversing, because let's say we have a D as well which is connecting to B, so therefore from D to C B will have some other values, so therefore we are storing a Q. First we are adding the same node, and from A to A it will be the weight of 1, because from same to same node we have 1 weight. We also are maintaining a visited array. Okay, so we are pulling out A, we are seeing B 1.5. Okay, we are pulling out A, we are saying that okay, this is not equal to the end, so therefore we will visit the array. We'll visit the neighbor. So in the visited array, let's say this is the visited, we add A. Okay, now neighbor of A is B. Is B visited? No, so therefore we will add B with the multiplication of the current node. Current weight is 1 into 1.5, it is 1.5. Alright, now we add it to the visited array. Then we again go to the next one. There is no next neighbor, so therefore we pull it now B. Now B's neighbor is C with 2.5. We add it to the we pull out B. We visited B, which first check is B is equal to the end node. No, so we visited the neighbor C. We check is C visited. No, so we add it first to the C, then C we multiply it till B. What is the weight we have received? 1.5. So 1.5 into 2.5, into 2.5. So we add it to the queue. Alright, so whatever it is, 1.5 into 2.5, it may be 3.75. So we added C with 3.75. Then whenever C is removed, we check is C is equal to the end node. Yes, so we return the weight till C 2.5. Okay. All right, I think that will do the trick. And yep, and if no, if the node doesn't present is not present, then there is no way we can find a route, so therefore we return -1. Okay, it's very similar to Dijkstra. In the Dijkstra we find the shortest path. Here we are finding the path, but we are returning the weight. Yes, so thank you, see you on the next video.